3-1 is called quadratic functions. So we narrow down our functions to just quadratics, which mean every single thing we graph will be a parabola. Every single equation will be an x squared, okay? But we're going to like learn how to find vertex, axis symmetry, domain, range, like a bunch of stuff based on these quadratics. They are no longer just approximations of what a parabola looks like. These are going to be much more specific. So just some basics. This is called quadratic form because we're going to go back and forth between what's called quadratic form and standard form. This is quadratic form, which is your f of x is now in the place of your y. And then it's ax squared plus bx plus c. The a, just like when we did quadratic formula, the a is what's in front of the x squared, the b is what's in front of the x, and the c is the constant. That's by itself. And we're going to use those for different things. When you locate your vertex, and there's a couple different ways to do that. Your vertex is obviously where your parabola changes direction. Your vertex has the variables hk. So the x coordinate of your vertex is called h. The y coordinate is called k. The axis of symmetry is the line that runs directly through the vertex. It is x equals h. So it's always x equals because it has to be a vertical line. And it always equals the h or the x coordinate of your vertex. And the minimum in this graph, because it opens upward, is the k value of your vertex. If it was opened in the other direction, so if it faced downward, then it's going to be a maximum value. But it is still the k. It's still the y coordinate of your vertex. Whereas the h is the x coordinate of your vertex. That's what I'm doing right now, no? Oh, okay. All right, so again, they're going to go back and forth between what's called quadratic form, which is this, and standard form. You'll know the difference between quadratic form has an x and an x squared, whereas standard form is just going to have an individual x squared. So when we're graphing using quadratic form, we're going to find the vertex by doing negative b over 2a. So if it's easier to see it in fraction form, negative b over 2a. And that gives you the h, or the x coordinate of your vertex. And then you're going to plug that back into the x of the equation to find the y coordinate of your vertex, also known as k. Then you'll plot that point. You can plot y-intercepts, you can plot x-intercepts, you can plot additional points by plugging values in to make your ending curve. So remember your y-intercept, you plug 0 in for x. And your x-intercept, you plug 0 for y. Usually there are 2 x-intercepts. If it crosses through the x-axis, there are 2. Sometimes there are 1. If it's on the axis, there's only 1. And sometimes there's none. If it's above it and points up or below it and points down, there are none. And then it can ask you things like domain and range, okay? Domain, because these are parabolas, are all real numbers every time. Domain would be all real numbers. Range, if it opens upward, then it's the k value, which is the y value of your vertex, to positive infinity. And if it opens downward, it's negative infinity to k. So both of those are going to be k because that's the y. So, I mean, you'll see, but on your quiz, there's only 4 questions because each one has so many parts. So 3 of them are going to be big chunk questions in which they break down into multiple parts. Vertex, axis symmetry, domain, range, x-intercepts, y-intercepts, all that, and then the graph. So there could be like 7 parts to one question. That's how those points will get broken down. Yes, sir?
Is that y a 0 or an infinite?
Is the next to the domain, you mean?
Yes.
This is infinity. All right, so we start with the ones that are basic because there are no shifts left or right or up or down. So if I look at this, there's nothing added or subtracted inside the parentheses. There's nothing added and subtracted after the squares, right? Which tells me I don't go left or right or up and down, and my vertex would be where? at 0, 0. So I'm going to plot a point at 0, 0 because there's no shift left or right. There's no shift up or down. What does the 2 on the front tell you? It's going to be narrower than normal or a vertical stretch, right? So to figure out exactly where it's going to go, I literally can plug in points. So I can plug in the 1. It would be 2 times 1 squared, 2 times 1, which is 2. And that's that coordinate point. And then it's going to reflect over the y-axis, which means this is my other coordinate point. If I had plugged in -1, I would have gotten the same answer. So I can make my parabola just from that. This time the intercepts would not have helped me because that 0, 0 is already the y-intercept and the x-intercept. So there was no other intercept to help you with it. You would have had to plug in those points. All right, go to 2. I'm going to do it on 2. We won't do it every time or we'll run out of time, but we are going to find a bunch, yeah. Okay, so looking at 2, what do I know about my vertex? 0, 0 again. This time that 1/2 times 1 squared would be 1/2 times 1, which is 1/2. So there's a vertical compression, which makes sense because it's a fraction. I would go the same in the other direction. And I could make my parabola from here.
So it's wider.
It's wider, yep. Now let's do all the stuff. So domain is what? All real numbers. Every single parabola. That's an answer to your quiz. That's 3 answers to your quiz. Okay? Every single time. Your range is what?
K.
Which is what?
The y value of the vertex.
Which on this one is?
0.
Good. And does it go first and then positive infinity or the other way around?
Goes first and then positive.
Good. Bracket or parentheses? Bracket on the 0, parentheses on the infinity. Good. How about your axis of symmetry?
0.
Good, but it's x equals 0. So it's x equals the h coordinate or the x coordinate of your vertex. Always x equals. If you don't have the x equals, you'll lose points because it has to be the line, right? This is actually this line.
Is that x or a k? They equal 0.
X. Yep.
Wait, what's analysis?
Axis of symmetry. Yeah. Sometimes it just says find the axis. It means the same thing. And again, the y-intercept and x-intercept both this time are both 0, 0 because it literally lands at 0, 0. It doesn't cross through anywhere else. So when it's that kind of situation, you'd have to plug in other points to know exactly where the other ones go. You need 3 points to draw your parabola, but you can use symmetry like we just used to find, you can find the vertex, you can find 1 point and then reflect it over the axis of symmetry to find the other one.
Do they have to be even?
They should be symmetric, yeah. Do they have to be? No, like I could plug in 1 and then I could plug in -2, I'd get another point. Is that what you mean?
Well, just like, do those exist?
Sure. Oh, like a non-symmetric parabola? No, doesn't exist. Yeah. All right, we're going to do 3, and then we're going to save 4 for tomorrow. So tell me about this one. What's different?
It goes down.
Good, it's upside down. So I know that it's going to point down. My vertex is still what? 0, 0. If I wanted to find, let's say I plug in 1, -4 times 1 squared, -4 times 1, which is -4. So 1, -4, and then I can reflect it over the y-axis to -1, -4, and I get my parabola. What's the domain?
Negative or real number.
Good. Negative infinity to positive infinity. What's the range?
K. Oh no, it's negative infinity to K.
Good, which this time is 0. And what's your axis of symmetry?
0.
X equals 0. Don't forget that x equals. And then x and y intercepts both 0, 0 still. Okay. We're going to do this one tomorrow. So we'll come back to that one. It's just wider. That's all. All right. So standard form is the second form. And it will be, these are like your transformation ones. So you will only have the squared once. You're not going to have an x and an x squared. For these, you can either plot your vertex by moving it right or left, up or down, and then find your vertex on your graph, or the opposite of what follows x is your h, and what follows the plus sign or minus sign is your k. You can get it directly from your equation, and then your line of symmetry is x equals h. So let's just say I have f of x equals 1/2 x plus 1 squared minus 3. What's h? It's the opposite of what follows x, right? So what would it be in this case? -1. What's k?
3.
-3. We don't change the sign on the k. So you change the sign on the h, but not the 3, right? Because we go the opposite direction when you do the horizontal shift, but you go the right direction if you're doing vertical shift. Which means my axis of symmetry for this is what? Good. So all that information you can get from standard form. Yep.
Oh, no.
Sure?
Yeah.
Okay.
So
It's
the
called the
LS is
negative
just
of-
the X.
Axis of symmetry. X equals the h coordinate. So the x coordinate of your vertex. Yep. So, and I would know this opens upward because it's positive. So I can also say domain from here is -infinity to positive infinity. And range is -3 to positive infinity. All of that stuff comes from the equation, and I don't even have to graph it. Xavier.
How did you get the vertex?
It's the opposite of what follows x, and then whatever's after the squared. Sean.
So then wouldn't you put -h, comma k for the vertex instead of just...
No, the h is the opposite sign.
Oh.
Does that make sense? That's why we change it. Because in our original equation, like if you look up here, the original equation is a minus h. So we change the sign on whatever's there to get the h. Joey.
You knew that it was like going up because the 1/2 is a negative?
Correct. All right, so there's going to be equations that are given to you in this format, like you're going to see, which we did using transformations is a lot of it, okay? And then there's going to be ones in which we're going to force it into this, which is that complete the square that we did a while back. We're going to bring that back in. So we start with the ones that are already in. And again, this is called standard form. So tell me what you know about this graph.
No, it's -2, -3.
Vertex is -2, -3. What else do you know before you even graph it?
Positive.
It's positive, so it's going to open in what direction? Good. What else?
The AOS
Axis of symmetry.
axis of symmetry is -2.
X equals -2. Don't forget the x. Domain. All real numbers. -infinity, positive infinity. Range. Since it opens up.
-3.
Good. And we haven't done it yet, but you'll see. Well, I'll go back to this. It's going to have a minimum value because it opens up, okay? And then we'll talk about that one.
-3 have like
Bracket.
yeah.
Yep, because it's not an open dot. All right, so -2, -3, shift left and down. Yep.
Is it because you know that it's a U-looking thing? I don't even know what it's called.
Parabola.
Parabola? Do you know that it automatically makes the domain infinite?
Yep. There's no restriction on it, right? No square root, no variable in a denominator. Yep.
Sorry, I'm not artisans. Did you say the test date got moved?
No, test is next Tuesday. Quiz got moved Thursday.
Okay, so it's not Wednesday anymore?
Correct. Okay, so then is this narrow, wide, or normal? Normal, which means on a parabola I can go up 1 and out 1 and find those points. So I can go here and here. Or I could plug in a point. I would want to plug in a point to the left or to the right of the vertex and then reflect it over if I do it that way. So let's say I wanted to plug in the -1. I could plug it in up here. I'd get -1 plus 2 squared minus 3. I'd get 1 squared minus 3, 1 minus 3, which is -2. And that also gives me that same point. And then I can reflect it over the other side. You don't have to plug it in if you know how to do the reflection, but at minimum you need 3 points. Summer.
So you can like, if you wanted to, you can plug in like any number at a certain point.
You could plug in anything except your vertex because you'd get a duplicate point. But literally you could plug in 0 and see where it crosses through. It doesn't matter.
For the vertex, you got -2 because of symmetry of line, right?
I got -2 because it's the opposite of what follows x. Then because that's my x, that's why the axis symmetry is there. Yeah. All right, so there's also a minimum value here because it opens upward. If it asks for it, the minimum is the k value of my vertex, which would be -3. Yep.
You said you could plug in any number for like the -1 plus 2 squared minus.
Yep, I could plug in 0, right? You'd get 0 plus 2 squared plus minus 3. And you'd get 4 minus 3, which is 1. So that's where that point would come from. And then if I went up and over, I went 1, 2, 3, 4 up, 2 out, then I'd have to do the same thing going the other way to reflect the point. That's all.
Okay.
Yep. As long as you have 3 points and you can use the third by using reflection over the x-axis or the axis symmetry, you could totally reflect it. But you need to at least have the 3 points to make the curve.
If there's no like number before though, you can just go 1 out.
Mm-hmm. Yep.
Is there any cases where like instead of going, so now you point it like 1 like to the side? Is there
Anything that's in front of it would change that.
no like it's 1 out on the x.
If only if the A is 1. If it's not, then it's going to change that. Yeah. All right, so that's first option is it's already in standard form, which it was, okay? And then we graphed it. Now this one is in quadratic form and there's no longer just a single term squared, right? So I don't know what this vertex is, okay? So this method, we just call the -b over 2a method. Like, I don't think it has any other name. It's not like complete the square where it's an actual process. But this is how we are going to find the vertex. One, the only thing I know from this is which direction it faces, which is what? Up, right? It's positive on the front. Well, I know 2 things. I know that it's positive, and I know what my domain is. Yes, which is? All real numbers, okay? Those I know just from looking at the equation. The rest of it I got to find. So I'm going to do -b over 2a to find the h. A is 1, b is -6, c is -14, but I don't need that yet. For what? The -b over 2a? Yeah, not there yet. Negative, what? -b over 2a.
Why would it not be all real numbers?
A domain? Never. Yeah, not for a quadratic. Always for a quadratic. That's why I said you know that answer from the moment you look at it. -b over 2 times 1 would be 6 over 2, which is 3. And that's the x coordinate of your vertex. Then I'm going to take and plug that back in. So I'm going to find f of 3. I'm going to plug it in. 3 squared minus 6 times 3 minus 14. And I get 9 minus 18 minus 14. -9 minus 14, which is -23. Now what's my axis of symmetry?
X equals 3.
Good. We said domain, right? Domain is -infinity to +infinity. I know this opens upward, so what's the range? -23 to infinity. Is there a max or a min? A min, and what's the min? -23. Good. You know all that stuff before you even graph it.
Wait, how do you know if it's max and how do you know
If it opens up, it's got a minimum, right? It's the lowest point, and if it opens down, it's a maximum. They're both the k value, though. Okay. Yeah. Okay, so 3 -23 is not on my graph. I don't want to have to draw out 23 spots. I'm going to go to 3. I'm going to go all the way down as far as I can go, and I'm going to label that 3 -23. Did I do that right? 3, right? 3 -23. Yep. That's your vertex. I don't want to have to go like, boop, 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 boop. I'm just going to mark it. Yeah. Now I got to figure out, I need 2 other points. I can either find the intercepts. So when I find the intercepts, to find the x-intercept, I'd actually have to solve this, which Okay, so we could find the intercepts, which would be easy to do if that was factorable, and it's not. So we're going to do it in a little bit where it's not factorable, but we're going to avoid it for the time being. Okay, that would be my x-intercepts. My y-intercept is if I plug 0 into x, so that one's easy. So I get y equals 0 squared minus 6 times 0 minus 14. And these will always cancel if it's in quadratic form. And so my y-intercept is negative 0, negative 14. So I can plot that one. And then I can either reflect it over here, if I wanted to count the exact, obviously this is not accurate, or I can plug in 1, and then I can reflect it. So it's up to you how you find your other points, but any of these you can use. As long as you have the exact point, that is your vertex, and then 1 to the left or 1 to the right, and then reflect it over the other side. So a lot of times you'll see in a little bit, it will say specifically find the x-intercept, find the y-intercept, find the vertex, and those obviously you have to find. But if it is not that scenario, like this is not something that's easy to find the x-intercepts because it's not factorable. If it was, then it's easy. But I'd have to use the quadratic formula on this one, which we're going to do in a minute, but we don't want to do it if we don't have to.
Wait, how do you find the reflective? I don't understand how you find the reflective.
You would just count up and over the same. So I didn't because this is not accurate. I eyeballed it. But if I wanted exact, I went up, right, from negative 23 to negative 14 is 9 spaces. So I would have gone up 9 and I would have gone to the right 3.
Okay.
If you want an exact point. It's just that this isn't exact because we are off the graph. Edward.
So,
All right, we're going to do one more. Vertex, axis, x-intercept, y-intercept, and graphed. So which way is this facing this time? Upside down. Okay, it doesn't ask for it, but that means it would have a max. And it doesn't ask for the range, but it would be negative infinity up to k. The vertex, this time A is negative 1, B is 6, and C is negative 8. So negative B over 2A is negative 6 over 2 times negative 1, negative 6 over negative 2, which is 3. So the x-coordinate of my vertex is 3. Plug it back in. Negative 3 squared plus 6 times 3 minus 8. I square it first, then take the negative. So this is negative 9 plus 18 minus 8. 9 minus 8, which is 1. And that's the k.
Why is the negative excluded?
Because it's exponent, then the negative. My axis of symmetry is what? X equals 3. Okay, this time it wants intercepts. So to find the x-intercept, we plug 0 in for y, which is the f of x. 0 equals negative x squared plus 6x minus 8. Can I factor this? Are there factors of positive 8 that sum to positive 6?
4 and 2.
Yep, 4 and 2. So I get negative x squared plus 2x plus 4x minus 8. And then I'm going to factor by grouping. Take out a negative x, x minus 2. Take out a positive 4, x minus 2. X minus 2, negative x plus 4, and split and solve. X equals 2, and x equals 4. So my x-intercepts are 2, 0, and 4, 0. And then the y-intercept from quadratic form is the easiest thing because it is just the c. And now I'm going to plot all that information. So 3, 1, 0, negative 8.
Wait, how do you get the y-intercept?
You plug 0 in for x. So if it's in standard form, this is always going to go away, this is always going to go away, and it's just the c left. 2, 0, and 4, 0. And there's my parabola. Yep.
How did you get the starting point again?
The negative b over 2a. Is that what you mean? Like my vertex?
What did we get for the vertex? It was 3.
3, 1. Yep. So negative b over 2a gave me the 3, and then I plugged the 3 back in and got the 1.
Okay.
We're going to go to the last one. So if we actually hold, and that is this. If you can plug numbers into an equation, you can do this part. 1, good news, no graphing. Okay? 2, a lot less complicated. So this is finding the standard form of a quadratic function. So I am going to give you the vertex and a point that it passes through, and you're going to give me the equation as the answer. So the vertex, you're going to make the h and the k. The point, you're going to make the x and the y, and then you plug it all back in, and the only variable left is a. You'll solve for a, and then you plug back in the x and y coordinate of your vertex, so the hk and the a, and then you're done. So they look like this. It'll say find the standard form of an equation given the information. So for 10, my vertex is hk, and this is my x, y. So you have to memorize y equals a x minus h squared plus k, because that's the standard form. The y is negative 6. The a you don't know. The x is 3 minus the h is 1 squared plus 2. So biggest mistakes people make on this is forgetting the squared on that. Obviously, don't do that. And order of operations says do what's inside the parentheses, then square it, and then for some odd reason, people add 4 and 2. You don't do that, right? You subtract the 2. Negative e equals a times 4, and then divide by 4. And a is negative 2. And then you plug back in the h, the k, and the a. So y stays as y. The a is negative 2. The x stays as x. Minus the h, which is 1, squared, plus the k, which is 2. I'm going to do the last one, just so you see it again. H, K, X, Y. Y equals A.
What am I supposed to plug in?
X minus H would be minus a negative 4, so this becomes plus 4. Squared. Oh, I didn't plug in the X, sorry. Negative 6.
Well, what did you have to plug in for time?
This equation.
Why? Oh, it's not like that.
Everything but the X and the Y. So X, good luck, Sean. Minus the negative 4 squared plus K, which is 11. Subtract the 11. And divide by 4. Simplify it, that's negative 3/2. And then you plug back in the A, the H, and the K. So Y equals A, which is negative 3/2, X minus a negative 4 squared plus 11. The last way to graph it is the most complicated because you have to complete the square. So you only want to do this if it says find standard form. It's going to say find standard form, but not all the time. If it doesn't, I would say go with the negative b over 2a method, okay? But if it says find standard form or write the equation in standard form and then graph, then you have to complete the square. So it's been a little while since we did that, and it's a little different because it's not equal to 0 anymore. We're going to start with something that looks like this. We're going to group the ax squared and the bx together. If A is not 1, we have to take out what's on the front of the 1. And that's a big difference from the first time. And the first time we did it, we divided everything by it. This time we got to take it out and leave it there. Then we're going to figure out what that middle term is by taking the second term, dividing it by 2, and squaring it. We're going to add that term to the parentheses and subtract it from the C, which is also different. We added it to both sides of the equation last time. And if there's something on the front, you have to multiply that term by it before you add it. And then you're going to factor it as the perfect squared trinomial. And then you're putting it in standard form so you are where we left off this last time. All right, we're going to do a couple examples. Hopefully that'll jog your memory. So it says put it into standard form, then find the vertex, the y-intercept, the x-intercept, and the axis symmetry. So step 1 is group them together. Leave the space. Step 2, if there was something on the front of the x squared, we would take it out, but there's not, so we are good. So we take the 6, ignore the sign because we're always going to square it, divide it by 2 and square it. I get 3 squared, which is 9. Now, when we did this in chapter 1, we added the 9 here, and we added the 9 to the 0 on the other side, but it's no longer 0, so we can't do that. We are going to instead add the 9 inside the parentheses and subtract it outside the parentheses to balance out that side of the equation. So we're keeping everything on one side of the equation. I'm going to factor what's inside the parentheses because I made it a perfect square trinomial. So square root the x squared, square root the 9, take the sign from the 6x, put it in parentheses and square it, and then negative 3 minus 9 is negative 12. And now my equation is in standard form. Huh? I factored it. Square root first, square root last, sign from middle because it's a perfect square trinomial.
So instead of bringing it to the other side of the equal sign, you just like move it over one?
Yeah, you keep it all on the right side. You can add it to the y, but then you have to subtract it at the end anyways. Yeah. Okay, so now what do you know about this parabola?
It's facing up.
It's facing up. What's my vertex? 3, negative 12. What's my axis of symmetry? X equals 3. To get my y-intercept, I'm going to get the x-intercept first because that's easier. My x-intercept, I would go back to the original one that's not in standard form because it's easy. Make this 0, and what's left? Negative 3. To get the y-intercept, I have to plug 0 in. No, sorry, this is the y-intercept. To get the x-intercept, I have to plug 0 in for y. Is that factorable? Are there factors of negative 3 that sum to negative 6? No. So I can either use the quadratic on this, or I'm going to take this because we haven't done it yet. 0 equals x minus 3 squared minus 12, and solve it. Add the 12 to the other side. Square root both sides, putting the plus and minus in front of the 12. That becomes 2 root 3. And then add the 3.
You couldn't just like do it normally to find it? Like,
It's not factorable. So you either have to do this one. If it's not factorable, you have to do the quadratic or solve it using the even root property.
but isn't that like different from the original even root property? Because you're not.
Wait,
I don't know what you're saying.
You know, there's like the other ways to do even root property where you move the c to the other side.
You mean to complete the square.
Oh,
Right.
that's different.
It's different because that was if it was equal to 0 and it's not equal to 0 anymore, it's equal to y. So now I have 2 x-intercepts, 1, 3 minus 2 root 3, and 1, 3 plus 2 root 3.
How do you graph that?
You would approximate it. So like root 3 is like 1.4. And you would I would actually approximate it from square root 12. I would say square root 12 is like a 3.5. And I would do 3 minus 3.5 and 3 plus 3.5. But if it's just asking for it, you want to keep it exact just how that is. So this didn't ask you to graph it. You would have to approximate it. It asked for the vertex, the y-intercept, the x-intercept, and the axis symmetry.
How many questions like that will be on the quiz?
So you could get them where you have to do this and graph it. There's two where you have to put it into standard form. But you could also use other points. Like I could plug in 1 to actually graph it. I don't have to graph my x-intercepts. It's going to ask for x-intercepts. I have to give them, but I don't have to plot that on my graph. I can literally plug in 1 and see where it goes. Does that make sense? Or I use the y-intercept and then reflect it. You could use that. As long as you've got 3 points, it doesn't matter what they are.
But you will have to get the x-intercept.
You will have to get the x-intercepts that are not factorable. Yeah. All right. We're going to do one more where it's round. It's not, here, where it's not a perfect square. I mean, where it's not something on the front. Is there okay, I'll do this one. So this one says, put in standard form, find the vertex, the y-intercept, the x-intercept, and axis. Okay, so step 1, group it. Bump the 1 to the outside. This time there is something on the front of the x. You have to take it out. So I take the 2 out, and by doing that, I'm dividing both of those by 2. So x squared minus 3 halves x.
Wouldn't it be -1?
No, you're just shifting it over. You didn't move it to the other side, so it stays the same sign. Now I have to take the b, which is 3 halves, divide it by 2, which means multiply by a half.
Wait, why does the 2 go to the front?
Because you have to take it out. You can't have anything in front of the x squared. So this would be 3/4. Square it, it's 9/16. And that's what you're going to add inside the parentheses. And to balance it, you would normally subtract it from outside the parentheses. But you have to multiply it by the 2 first. So if there's something you took out, you have to multiply it by that value before you combine it with the last one. Which means I am now subtracting 9/8. And I get y equals the 2 is still on the front. Square root the x. Square root the 9/16. Take the sign from the middle, put it in parentheses and square it. And then +1 and -9/8 becomes 8/8 minus 9/8 or -1/8. And there's your standard form. What's your vertex?
3/4.
And?
1/8.
-1/8, good. What's your axis symmetry? Good. For your y-intercept, go to the beginning. What would you get if you plugged in zeros? 1. And then your x-intercept? Are there factors of 2 that sum to -3?
Yeah, negative.
So now we can factor it, right? So 0 would equal 2x squared minus 3x plus 1. You could do trial and error, or you could do first times last, but it'd be -1 and -1. So x-intercepts, 1/2 0, 1 0. Yeah.
Wouldn't it be -2 and -1 because that equals -3x?
If you do first and last, I just did trial and error.
Oh.
So if you do first and last, your middle term should be, yeah, -2x and -1x, and then factor by grouping, you should still end up with the same answer. Yeah, I just did trial and error because they were prime. Questions? We're not done. No, I see you packing up. We're not done. The good news is what's left is, that's why I kind of save it for the end, is super easy. So we're going to jump in. Yeah.